Hello everybody, so today we're going to talk about how to find the volume and surface area of 3D shapes. For today we're just going to look at two types of shape, cubes and cuboids. Now a cube, as we probably know at this point, is like a 3D square, so it has 6 sides, all of which are identical. A cuboid is like the rectangular version of that, so it's a rectangle that's been made 3-dimensional, or you can think of it as being a cube that's maybe a bit longer at one side. So we'll look at examples of both of those. We're actually going to start with cuboids though. So a cuboid, like we said, is a rectangle that's 3-dimensional. So it might look a bit like this. Now the formula for finding the volume of a cuboid is to multiply its length by its width by its height. And which you'll see in the diagram as being its 3 dimensions. So we can say that this is the width, this is the length, and then this dimension here is the height. Again, to find the area, you'd multiply all those three together. And when we talk about the surface area of a 3-dimensional shape, it's kind of similar to 2-dimensional area. If I asked you to say the area of a rectangle, you'd be able to do that by multiplying the length by the width. But because the shape exists in 3 dimensions, we have to find the surface area of the top of the shape, the bottom of the shape, the back and front, and the 2 sides. So we treat them like 6 separate rectangles. So an easy way to visualize this might be what we have here. So if we picture our cuboid as being a 6-sided shape, we can draw out a map of the different sides. So we could say this is our front, so we draw a map of the front. Attached onto the top of the front is going to be the top of the shape. Then the bottom, you'll have the bottom of the shape. So we represent them in green here. This is the top, and we can imagine there being a green surface on the bottom as well. Also attached to the front is the right hand side, and the left hand side will be on the other side. So now we have 4 different surfaces, but actually there's 5 different surfaces, but there's actually a 6th at the back, which we just show here. Now this connects to any of them, so we could have it connected on here, or we connect it up to the top, because it would also be around the back of the top. So once you have a net drawn out like this, to find the surface area, you just find the surface area of each individual shape here. In this case, they're all rectangles, then add them together. So to find the area of the bottom, it would be the length times the width. To find the area of the top, it would also be the length times the width. So part of the total surface area is going to be 2 lots of the length times the width. So this is the 2 green areas. To calculate the surface area of the front and back, the purple sides, would be the length times the height. And this would be the case here and also here. Again, there's 2 of them, so we'll add on 2 of that area. And finally, to find the area of the sides, it's going to be the width times the height. So we'll multiply them together to get one of these areas, and then add a second one. So we have 2 of them, to find the opposite side as well. This gives us a total formula for the surface area of being 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Or again, it would be 2 times, well, the area of the top and bottom, the area of the front and back, and the area of the 2 sides. Remembering that they all come in pairs. If we look at a cube, things become a little bit simpler, but the principle is the same. So we have a square that's 3-dimensional. Now the thing about the cube is that all of its 3 dimensions, its length, width, and height, are the same. So instead of labeling them separately, we can just say that this is a length. We can say that the height is also just a length. And we can say that the width is also just a length. So we end up with the same dimension 3 times. This means that when we try to find the area by multiplying the width by the length by the height, that actually all those three values are the same, so we can just call them all L. So L times L means that we just get one length and cube it, which just means multiplying it by itself 3 times. So this is a special case for the cube, and it has its own special formula. And you can use length by width times height if you want, but this might just be a little bit faster. It'll also help you out with some scenarios where you're asked to solve problems because you'll only have one unknown variable as opposed to 3 different variables. When it comes to finding the surface area of a cube, we have a similar shortcut we can use. So if we look at the net that we can draw for a cube, we've drawn all of our different area or different sides out, and we still have 6 different rectangles, but each of those rectangles is actually a square this time as well. So if we wanted to find the area of each one of those, it would be the same length by itself. So just like our length, width and height were all the same, all the dimensions on this surface area net are going to be the same. So L times L here will give us L squared. And then for each of the other squares, they're also going to have the surface area of L squared. So that gives us a total surface area of 6 lots of L squared. So you can say the surface area is equal to 6 lots of L squared, or 6L squared. So that's again the same formula really for the surface area of a cuboid, but it's just a slightly easier version to work with because it just means there's 2 variables here. We have the surface area and we have the side length of the square L. So we can have a look here at an example of a cuboid. We have an unknown width and we're told the total volume is 540 centimeters cubed. So again, the first step is just to identify what shape we're dealing with, just like when we looked at 2D shapes. So this shape is a cuboid. Now we're going to have a look at what formula we'd use to try and solve this question. So we're looking to find the width and we're given the volume. So that means it's a pretty good idea to start by writing out the volume formula. The volume for a cuboid is length times width times height. The next step is going to be to start filling in what we know from the question. So if we want to fill in the volume, it will be 540 centimeters cubed. Width is unknown. The length is 12 and the height is 5. If we try and multiply this out now, we should be able to solve it. Again, what we're looking for here is that we've set up an equation that only has one unknown, which we have. Only W, everything else we're able to fill in. So 12 times 5 is going to be 60, times W will be 60W. Now to get W by itself, we're going to have to divide both sides by 60. On the right hand side, these two will cancel. So we'll get W is equal to 540 divided by 60, which gives us 9. And now we're looking to put a unit in as well, because we're talking about measurement, so it's going to be centimeters. Again, we get centimeters because that's the unit we were dealing with in the question. If we were now asked to find the surface area of the shape, we can have a go at doing that. So again, we first of all try and identify the shape. We know it's a cuboid. And the next step will be trying to find the formula that we're looking to use. So this question specifically asks about surface area, so we'll try and use the surface area formula. Again, the formula is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Now, before we start filling this in, we actually know the width at this point. We know that that's equal to 9 centimeters. So now we can start filling in all of our lengths, widths and heights, and hopefully that will allow us to calculate our surface area once we're done. It doesn't really matter which you call your length, your width and your height, but what is important is that as you're filling them into the formula, you don't get them mixed up and start calling different ones length and width and height. So we might just write them all out first before we do this. So we can say that the length is 12 centimeters can say the width is 9 centimeters. You can say the height is 5 centimeters. Again, it doesn't really matter which order you put them in, it's just as long as you don't get them mixed up when you start putting them in here. So decide before you start using this formula. So when we have them all filled in, it'll look like this, and now we'll just try and multiply each of them out. Okay, so we've got them multiplied out now, and then we'll finally just solve the surface area by adding. This gives us a final answer of 426 centimeters squared. Again, because it's measurement, we're always going to have a unit, and because it's area, that unit is going to be squared, so we're going to take that area from the base unit here given to us in the question, which was centimeters. One other important thing to remember is that when we're solving these questions out, that we use BIBMIS when we're working through the solution. So here we multiplied first, then once we've multiplied each block, we added them together afterwards. Again, just because multiplication comes before addition in BIMDIS. So try and keep that in mind when you're going through these longer type of questions.